Okay, so this is the continuation of the exercise 4, layer 4 to 7 of the OSI model. So step 1, connect to PLAB Win 10. Restore the network and sharing center window and click on the Windows firewall link located on the lower left corner of the window. Okay, so let's just click it. Okay, so on step 2, click on the advanced settings. Click link on the left pane. Okay, moving on to step 3. Click on the inbound rules in the left pane. View the middle pane which contains the inbound rules. Okay, moving on to step 4. Okay, so look for the following application layer protocols. So first thing is core networking dynamic host configuration protocol DHCP in remote desktop user mode SNMP. CAS to device streaming server HTTP streaming in. These are just some of the application layer protocols and services that are running on the Windows device. These are network-aware applications that service the user applications utilized by the persons operating the device. Click, click the window firewall with advanced security window and Windows firewall window. Okay, on step 5, right click on the taskbar and click the Task Manager menu item. Okay, so Task Manager, Task Manager menu item. Okay, moving on. The Task Manager window appears. Then step 7, maximize the Task Manager for ease of use. Scroll down to the Windows Process section and find a service called Service Host Network Service. There may be multiple instances of this expand device. Okay, so step 8. After expanding it, you can see that this process is responsible for the NS client network location awareness as well as the remote desktop services. All of these are network applications and services that require this process to run. This process runs just below the network-aware applications such as web browsers, email clients, remote desktop clients, and other such software packages. This is the application layer of the OSI model in action. So next up is close the task manager window. Okay, moving on. Exercise 5, contrast TCP and UDP protocols. Transmission Control Protocol, which is in short TCP, and User Datagram Protocol UDP are protocols that work on layer 4 of the OSI reference model. There are different applications layer protocols like HTTP, SMTF, FTF, etc. But how do they work and what is the difference? So HTTP, SMTP, DNS, and similar application layer protocols use different layer 4 protocols and different port numbers to communicate. For example, HTTP uses TCP port 80, SMT uses TCP port 25, and the third one is DNS uses UDP port 53. TCP is a connection-oriented protocol. UDP is a connection-less protocol. In TCP, before end hosts can send data to each other, a TCP connection needs to be established between them. This makes TCP a reliable protocol because every packet sent needs to be acknowledged. TCP guarantees delivery packets sent over a TCP connection are checked for errors before they are transmitted over the network. UDP is a connectionless protocol, hence it doesn't acknowledge packets, does not guarantee packet delivery. Packets are not checked for errors before transmitting them over the network. Applications that require high relativity, speed, and quick delivery of packets use TCP, hence TCP is used for HTTP, SSH, FTF, email, and many others. UDP is used for applications that require a faster delivery and does not need to be checked for any odd errors. For example, voice streaming, video, DNS, and many others. In this exercise, you will capture packets and then identify TCP and UDP packets. To better understand this technology, also refer to your course material or use your preferred search engine to research this topic in detail. So the learning outcomes. After completing this exercise, you will be able to capture packets, identify TCP packets, identify, identify UDP packets, then your devices. You will be using the following devices on this lab. Please power on this now, which is PLAB SA01 Windows Server 2016 member server. Okay, let's just wait now for to load. Okay, so task one, capture packets. In this task, you will capture packets to identify the protocol being implemented. To capture packets, perform the following steps. Step 1, connect to PLAB SA01. Okay, let's just wait for it to load. Okay, so first thing, step 1, launch Wireshark from the desktop. Okay, so step 2, the Wireshark network analyzer is displayed. Okay, step 3, select internal and click capture. Okay, on step 4, captured packet should begin to appear in the top pane. Step 5, Wireshark windows display the details of data packets being exchanged among the device. You might not see many packets at first because there is not much traffic on the network. However, they slowly begin to appear. Scroll down to see additional packets that are captured. Notice that multicolored coding of the packets. Each color represents of the protocol that the data packets implements. Okay, on task 2, identify TCP packets. In this task, you will identify packets implementing TCP protocol and ports used. To identify TCP packets and the ports used, perform the following steps. So step 1, ensure that you are connected to PLABSA01 and ensure the Wireshark windows is open. From the Wireshark window, enter the following in the filtered drop-down text box. Okay, so let's just copy this. Okay, and paste it over here. Then let's click the blue arrow. Okay, so worked. So moving on to step 2. Notice the change in the color coding of the data packets. Only the data packets implementing TCP protocol are now being displayed. Okay. Select a TCP packet from the list displayed. The second pane shows details concerning this segment. Okay, step 3, expand the transmission control protocol section. In the second pane, notice the source port of the destination port. In the following example, they are 3389 and 8651. Okay, so let's expand transmission control protocol. It's over here. Notice that the source port and